Okay, so let's continue this homework with two other questions from page 499. Number 20 asks us to calculate the hydrogen ion concentration in a saturated solution of calcium hydroxide. So we're taking calcium hydroxide and dissolving it in water. That would leave the calcium ion and hydroxide ion, and balancing it leads us to say that we have two of those. We know that our concentration of calcium hydroxide is 6.9 times 10 to the minus 3 moles per liter, because it's millimoles per liter. That can let us write what the concentrations of each of the cation and anion would be. Concentration of calcium ions is the same, 6.9 times 10 to the minus 3. And the hydroxide ions would be twice that number. So that's 1.38 times 10 to the minus 2 moles per liter. Now we want to figure out the hydrogen ion concentration. We're looking for the H plus concentration. Well, we know the H minus, the OH minus, the hydroxide ion concentration, so we can plug it into our handy-dandy formula here to figure out the hydrogen ion concentration. It is 1 times 10 to the minus 14 divided by 1.38 times 10 to the minus 2. We'll bring up our calculator and take 1 times 10 to the minus 14, divide by 1.38 times 10 to the negative 2, gives us 7.25 times 10 to the minus 13. Moles per liter. So we'll take a look at question 21, which is what is the hydrogen ion concentration in a solution made by dissolving 20 grams of potassium hydroxide in water. So potassium hydroxide being dissolved in water would leave potassium and hydroxide. All of those charges are ones, and therefore it's balanced. We are putting 20 grams of potassium hydroxide into 500 mils of water. So we need to figure out the number of moles of potassium hydroxide. We do that by taking the mass dividing by molar mass. The molar mass of potassium hydroxide is 39.10 for potassium, plus oxygen and hydrogen. So that is 56.10, maybe another one of that. So 0.11, I guess, grams per mole. So now we have 20 grams divided by 56.11 grams per mole. We can now deduce the number of moles. So we have 20 divided by 56.11 gives us 0.356. 0.356 moles. And our concentration for KOH is the number of moles, 0.356 moles, divided by the number of liters. Well, then that's doubling this, so we get 0.712 moles per liter. That is also the concentration of potassium and the concentration of hydroxide ions. And we're looking for the hydrogen ion concentration. To get the hydrogen ion concentration, you take 1 times 10 to the negative 14 and divide by the hydroxide ion concentration. So our lovely number will go straight in there. H plus 1 times 10 to the minus 14 divide by 0.712. We go to our calculator again, and we take 1 times 10 to the negative 14 over 0.712 gives us 1.4 instead of the minus 14. Moles per liter. And that would be our answer for the last question. Hope this has helped.